Hello, everybody, and welcome to the Astro Show, a place to be if you're curious about the cosmos. I'm your host, Dr. Sam, the founder and executive director of Wyoming Stargazing. Here, you can pick the brains of astrophysicists, get advice from an aerospace doctor, find out about what astronomers and other scientists have to say about life, and find out what's going on above your head all in the same place. So, we hope that you join us every second and fourth Tuesday of the month at 6 p.m. Mountain Time on YouTube, Twitch, and on Facebook. So thanks for joining us tonight. We've got a fun show for you. Our special guest is Madeline Eatonton from the University of Virginia. Among other things, Madeline studies the cosmic microwave background radiation from the epoch of recombination. And we will hear all about that later on this evening. But before that happens, let's welcome our co-stars. First, astronomer and data visualization engineer at the Adler Planetarium, it's Dr. Lauren Corlees. Hey Lauren, how you doing? Oh, you're muted.
So silly. Good to do it in the beginning. Hi, everyone.
Very good. Good to see you. All right. Next, aerospace doctor and founder of Orbital Biodesign, it's Dr. Danny Carroll.
Hey, everybody.
Hey, Danny. Good to have you back.
Good to be here.
Next, actually, last but not least, we're still waiting for one other person, assistant professor and astronomer at the University of Texas at Austin, it's Dr. Nick Galitzky.
All right. Hi, everybody.
Hey, Nick. Good to have you back as well. And Valerie Steinbeck might be joining us later on. We're not sure about that. Hopefully she does. But in the meantime, let's welcome on our special guest, Madeline Eatonton. Hi, Madeline.
Hi. Thanks for having me.
Yeah, thanks for being here. We're psyched to have you. Well, I'd like to start off the show with just everybody just saying a couple words about what they are up to in research or their jobs, and then we'll get going with the show. Let's see. Madeline, do you want to say just a quick word about what you're up to?
Yeah, so I'm a first-year graduate student and NSF fellow at University of Virginia, and I am primarily studying cosmic microwave background, and you'll get to hear about that later, so I'll spare you the gory details for now.
Excellent. Thanks so much. Dr. Nick.
Yeah. What am I up to right now? It's recruiting season. I'm trying to find graduate students and postdocs, and working on building up a lab here at UT Austin, which is fun, but a lot of it more on the administrative side.
Right on. Lauren?
Yeah, so I'm currently working on a new project at the Adler where we're trying to make a virtual field trip for students, primarily centered around climate change, which is fun. It's a totally different topic for me, and it's really cool to get to learn about all this neat science that's happening and to think about how to share it with a bunch of middle schoolers. So
that is super cool. I can't wait to see that.
Yeah.
And Danny.
Hey. I've been spending a lot of time in the operating room lately. Not gonna lie, it's been pretty busy on that front. But on the research front, we are continuing to move forward with some of the spacesuit glove work in particular that we've been doing, and there have been some pretty exciting happenings on that front too. So
very, very cool. We can ask you a little bit more about that later on. All right, folks, here we go. We're going to get started with Astro advice, but a couple little tidbits to look forward to for tonight's show. We've got some stuff from the European Space Agency stuff we're going to be doing, a little bit about the coming comet, and Spaceport Nova Scotia. So keep all those things in mind for the news quiz later on. But now it is time for Astro advice. So I'll read the quotation, and then all of the co-stars will have a moment to ponder who they think actually said this wonderful piece of advice. So here it is. You cannot hope to build a better world without improving the individuals. To that end, each of us must work for his own improvement and at the same time share a general responsibility for all humanity. Our particular duty being to aid those to whom we think we can be most useful. So, your four options for who actually said that are A, Katherine Johnson, the American mathematician whose calculations of orbital mechanics at NASA were critical to the success of the first and subsequent U.S. crewed space flights. In 1958, she became the first Black woman engineer at NASA, and of course, recently portrayed in the movie Hidden Figures. B, Marie Curie, the Polish and French naturalized Nobel laureate, physicist, chemist who conducted pioneering research in radioactivity. C, Jiansheng Hu, Chinese-American particle and experimental physicist who made significant contributions in the fields of nuclear and particle physics. She worked on a Manhattan Project and did a lot of other amazing work in particle physics. And D, Mae Jemison, American engineer, physician, and former NASA astronaut, became the first Black woman in space. Oopsies. Nobody saw that. I didn't do that. Everybody ponder. Who would they think said that quotation? Usually we have another slide there that actually has all four of them again and the quotation. That's why I was advancing, but little did I know that was not there this evening. So please humor me and ignore what you just saw behind the curtain. And Nick, we'll start with you.
No, I'm feeling really good about Mary.
Oh man, the irony. I figured you'd have something good to say about that, Nick. So thank you. Oh goodness. All right. Well, let's just cut to the chase, shall we? That was Marie Curie, and I think this is fantastic, and I am curious what the rest of you have to say about it.
It feels a bit like an apt New Year's resolution. Good thing we're tagging this in January.
Yeah, you think that she wasn't behaving how she thought she would behave? Is that what you're saying there?
Time does. A new year, new start. Yeah, that's what I'm getting from this. Yeah.
So, for what it's worth, I actually was going to say Marie Curie.
Of course you were.
But I think that this quote actually is particularly true for people like me in medicine, where on a daily basis, you're impacting like one life at a time. But in the bigger picture, I think the thought at least is that it has farther reaching effects, the stuff that you do, and there's kind of like a downstream effect to all of those things. You're taking care of somebody's grandfather or somebody's niece or something like that, and then, yeah, it creates ripple effects in the universe, I guess. So.
Nice. Thanks, Danny.
Yeah, that was the part that I had sort of honed in on too, it's like calling out for an intentionality and how you're trying to be helpful. But I think it's also like bringing things in scope. Like I'm thinking about climate change a lot, and it feels really overwhelming. So it's this huge problem that like I cannot solve as an individual, but thinking about ways, how can I personally be the most useful in working towards a solution is the part that still gives me hope that like I don't need to solve everything, but if we all work together to solve it in the best way that we can, we'll actually make some progress. So.
I definitely approached it in a very similar way to you, Lauren. I was thinking about it from an astronomy and a science perspective, and it's all such a collaborative work that there's an important and integral part of science and furthering knowledge and technology is working together and using everyone's unique skills and building each other up.
Well said. Well said.
And it's interesting that she used the word useful, right? It's not like beneficial or like a good thing to do, but like literally like a utility. Like this is a useful thing that is helpful that we should all be doing, which I like as well. So
Yeah, I cued in on that as well, Lauren, and it occurred to me that if nothing, Marie Curie was probably a pragmatist. She wanted things to work. So I think that's what she was getting using that word. Any other thoughts? Alrighty. Well, let's move along to Astro 365, this day in astrophysics history. So, on this day in 1986, the Voyager 2 space probe made its closest approach to Uranus, detecting previously unseen moons and two more rings over the course of a few days. Some of those discoveries were actually made on November 24th, and a couple others were the 25th and the 26th. But some really amazing discoveries and some beautiful pictures that were taken in 86, which I just wanted to show. So on the right is this beautiful little crescent Uranus as Voyager passed by and was heading away. I turned around and snapped that picture on the right there. Beautiful kind of green hue from Uranus's upper cloud banks. And then on the left, the moon Miranda, which has got to be one of the coolest moons in the solar system with these like huge cliffs and valleys. We're still not totally sure how that all happens on such a tiny little moon. But impressively stark relief captured back then. And rumor has it that the James Webb Space Telescope that we're calling the Margaret Burbage Space Telescope is going to take some pictures of Uranus. You probably saw the amazing pictures of Neptune that were taken. Apparently Uranus might be next. So I am excited to see that when it comes along. So it got me thinking. This was where Voyager was in 1986. It got to within about 50,000 miles of Uranus, which is pretty close. But it got me thinking, where are the Voyager spacecraft now? And NASA has this, incredibly cool website that hopefully I can figure out how to click on here and open it up. No? All right. I'm gonna open it up on another page, hopefully, and share it with you here because it is so cool. It's definitely worth seeing. I can make it work here for us. Oh yeah, there we go. All right, I'm gonna share that for you in just a moment here. There you go. Hopefully you can see that. So really cool graphic of the solar system and where some spacecraft are out beyond it. Voyager 1 being the farthest, and I can bring up a little bit of information there. I was able to yesterday. There we go. Let's see. Why is the information that I wanted to show you not showing up today? Well, there were some cool details that I was able to pull up yesterday, but for some reason I'm not getting the same stuff that I was. But regardless, you can see, maybe, you can't really see how far away it is from the solar system in that view. Well, technical difficulties, folks. I'm not sure how to get this website working like I had it working last night. Anyways, Voyager is, if I'm remembering correctly, about 18 billion miles away right now, well beyond the magnetic boundary of the solar system. and still cruising away at about 37,000 miles an hour, I think, something like that. And Voyager 2 also is beyond the boundary of the solar system, not quite as far away at about 14 billion miles. But even at those incredible speeds, it's something like 400,000 years before they get to the next star system. So still quite a way away from the next closest star.
Yeah, and I just wanted to add that website is free. So if you're interested in exploring it yourself, that's just NASA's Eyes. They have a whole series of these sorts of interactives. You can do NASA Eye on the solar system or NASA's Eyes on exoplanets, and really interact with all those sorts of data as a model for yourself if you'd like.
Yeah, thank you for mentioning that, Lauren. It is a super cool website. I still apparently need to play around with it a little bit more to figure out how to work it the way I want. But yeah, there's some really cool digital overlays that you can find there. All right, let's get back to the slides. There we go. And it is now time for everybody's favorite part of the Astro Show, the Astronomy News Trivia Quiz. And as we mentioned earlier, we are doing it all lightning round now. And so folks, as soon as you think you know the answer, you can just shout it out. And person who gets the most points will be our champion this week. Are you ready? All right, Nick says he's ready. I guess that means everybody's ready. All right, here we go. Question number 1. Which
Aldrin.
Oh, nicely done, Madeline. Wow. I'm impressed, Madeline. Indeed, it was Buzz. My understanding that it was his 4th marriage. And here's a great shot right after the ceremony. So congratulations, Buzz. And his new wife, Dr. I always forget her name. Oh, I've got nothing. Madeline, do you know that for a bonus point? Someone he's been working with for a while, Frar. Thank you, Maggie, behind the scenes. All right, so 1 point for Madeline. Here we go. Question number 2. Next Monday, which planet will reach its highest point in the sky? Greatest illumination. Oh, who said what? I didn't quite catch that.
Mars. Why not?
Nope, not Mars. Sorry, Nick.
Just name a planet. Saturn.
Venus.
Nope, you're close, Danny.
Jupiter.
Mercury.
Mercury.
Mercury. I think I heard more say it. Mercury. Yeah. Mercury reaches its greatest elongation next Monday in the morning sky. So if you're an early bird, and maybe that's you, Madeline, since you're a radio astronomer, as opposed to us night owls who are not radio astronomers. Early morning in the east, you might get a chance to see Mercury close to the horizon, still as always, but visible. All right, so 1 point for Madeline, 1 point for Lauren. Here we go. The European Space Agency has named its upcoming Earth-orbiting satellite Arrakis. I heard something. Who said that?
Dune.
Dune. Who was that? That was Madeline. All right. Nice job. They named it after a beloved place from the sci-fi novel Dune. Anybody for a bonus point? What is that satellite looking for? What is Arrakis looking for?
Spice, obviously.
Not spice. No, I'll give you a hint. You can't see it.
Water vapor?
More exotic than that.
Dark matter?
Dark matter, Nick. Nicely done. All right. So that's a point for Nick. So we got two for Madeline, and 1 for Lauren and Nick. Here we go. This past weekend, we celebrated the Lunar New Year and welcomed
It's
the.
count.
Yes. Lauren. In Vietnam, they share 10 of the 12 zodiac signs with China, but there are 2 that are different. And instead of the rabbit, they have the cat. So it is the year of the cat in Vietnam. Okay, 2 for Lauren. Nicely done. Okay. Last week, NASA quietly suspended efforts to fully deploy a solar array on blank spacecraft, citing diminishing returns as the spacecraft gets farther away from the sun. Which spacecraft did they quietly decide not to keep working on? They say it's okay. It's like 90% correctly deployed, the solar array, but not 100%. I'll give you a hint, but then someone's going to get it. So the one step away from the real hint is that it has to do with the Beatles song. It has to do about the sky.
Lucy?
Lucy! Nicely done, Nick. It is the Lucy spacecraft. Yeah. One of the solar arrays didn't unfurl and then latch correctly. So it's depicted there as just kind of like hanging out. There's that little gap in it. So no, I guess they're not worried. They think it's going to be able to power the spacecraft just enough. So we'll find out when it comes back and makes its next closest approach to Earth. I think in about 1.5 years. All right. Oh, and if you're interested in what Lucy is doing, it's actually doing some really cool stuff. It is going to be making some flybys of some asteroids, not in the main asteroid belt, but the Jupiter Trojans. So I guess the first spacecraft is actually going to fly by several of these Trojans over the course of its time up in space. So pretty cool stuff. So Nick, does that give you 3 points? Do you have the lead now? I think you do. I think it's two for Lauren, 2 for Maddie, and 3 for Nick. All right, next question. What does the ZTF in Comet C 2022 E3 ZTF stand for?
Zwicky Transient Factory.
You got it, Lauren. Yeah, the Zwicky Transient Facility. Yeah.
Facility, yeah.
So hosted in several different telescopes, but notably at Mount Palomar. All right, so I believe that is that 3 for Lauren. So now we have a 2-way tie between Nick and Lauren. All right, we got a few more questions to go here, so plenty of opportunities. Okay, next question. Which country announced a 50 million pound...
UK?
Yeah, the UK.
That would be the UK.
People live under a rock.
Saving people's lives.
It's horrible.
It's okay.
50 million pounds for projects that would boost the country's satellite communications industry. Yep. All right, so Nick takes the lead with 4 questions. All right, here we go. Next question. With the construction of Spaceport Nova Scotia,
Canada?
there we go. Nicely done, Nick. Wow, you're quick tonight. You're cleaning up. It's pretty cool. They're going to build a spaceport. Not exactly sure what the end result that's going to be, but here's the rendering of what it might look like, and I think it's pretty cool.
I wonder what times of year they'll be able to actually launch.
You know, that's a great question.
Because it's limited.
Is that mostly a tourist thing, or because it's not really a great place to launch satellites, right?
Yeah.
No, they're talking about launching commercial satellites. Like I say, I don't know what the end result of what this is going to be, but yeah, I mean, apparently it's going to be a legitimate commercial launch facility.
Wow.
Yeah, I was surprised as well, but go Canada.
I'm trying to think of this.
It looks like an airport, right? It doesn't look like. That's why I was also thinking like tourism. I don't understand. But,
Yeah. I mean, I mean, eventually we're going to have tourist spaceports, right? I mean, it's kind of what I'm looking forward to before I go.
Oh.
Just saying.
I was going to say, I don't think it helps to launch a polar orbit by being closer to the pole, but then what do I know?
Yeah, I don't know about that. Yeah, maybe they know something we don't know. All right. Next question is not super exciting, a little bit more depressing, but a good fact for everyone to know. What has increased in the sky by about 10%?
Orbital debris.
Good guess, Danny. I actually thought that was going to be that.
Micrometeoroids.
What's that?
Micrometeoroids.
You're on the right track. It is from the ground initially.
Is that sky glow?
Sky glow, yeah, it's light pollution. Yeah, it's really sad. It's way more than what was predicted. The prediction was, maybe 2 to 5% increase a year over the past decade, but the latest data were just published, and yeah, 10% a year for the last decade. So I talked to a buddy of mine who's big into promoting dark sky certification. He's like, look, I'm trying to use this as an opportunity to get people excited because we need to now. This cannot wait. So hopefully folks are listening out there and you do what you can to shield your upward facing lights at night to reduce sky glow and light pollution. It is becoming a real problem, and we want to enjoy the night sky as well as to be able to do research on it, and you need it to be dark in order to do that, unless you're in a radio astronomer, and then it doesn't matter. All right, is that 5 for Nick or is that 6? I've lost track.
I think it's
5, is that what you said? Okay,
I'm in charge of answering the questions, not keeping track of this.
Three more questions. Here we go. Next question. What did amateur astronomers discover next to the Andromeda Galaxy that had never been observed before?
Is this the O3 emission?
It is the O3 emission.
Yeah.
There is this weird, doubly ionized oxygen nebulous arc that has apparently been hanging out there next to Andromeda for a really long time, and we just got too excited about taking pictures of Andromeda and didn't think to look there in O3, but there it is. Yeah, nobody has any idea of what it came from and whether it's actually connected somehow to Andromeda or whether it just it appears in the same apparent field of view. We don't know, but these amateur astronomers found it, and it's been confirmed by other telescopes. So it is definitely there.
It's super cool because we think that diffuse gas is everywhere outside of galaxies, but actually seeing it in emission is super hard. And so the fact that this one's just been hanging out there, it's really cool.
Yeah, it only glows in this tiny little bandwidth, this O3 emission. So yeah, I mean, they got super lucky on this one, but it's pretty cool stuff. So nicely done, Lauren. All right, 2 more questions. Here we go. What is visible on the face of the sun this week, even without using a telescope, but with a solar filter?
Sunspot?
It is a sunspot. Yeah, a giant sunspot. We're talking almost the size of Jupiter. It is a big one. It's the second largest sunspot that's been seen in the last 10 years or so. So that's it, right in dead center there. And yeah, apparently it's so big, if you just hold some welder's glass up in front of your face, you can actually just hold it right between you and the sun, and you can actually see it naked eye without a pair of binoculars with special solar filters or telescopes. So check it out. It'll only be visible for the next few days, and then it will revolve around to the other side of the sun. You won't be able to see it, and who knows if it will still be there when it reemerges. I think the sun's rotational period is 20 some days, so it could probably will be gone by the time that area of the sun comes back around to our view. So check that out. And you can see it from anywhere on Earth. It doesn't matter where you are. All you need is to find some welder's glass and take a look at the sun at some point during the day.
Except Chicago, because it's supposed to snow the next few days, but we'll see.
You will need to have more or less clear skies. You could see it through a thin cloud layer,
right?
But not a really thick cloud layer.
Hopefully, it'll still be there when the clouds clear up. I'll go check.
Yeah, we shall see. We shall see. All right, last question, and this one is so cool. I really enjoyed reading this article, and I love learning about this kind of stuff. Here we go. A novel propulsion system, this is legitimate, would hurl hypervelocity what at a spacecraft to speed it up to speeds of over 350,000 miles per hour.
Is it using nukes?
It's not. No, there is another proposal to use nukes. There are problems associated with that. It turns out.
Yeah.
But no, this is actually like pretty benign stuff that is going to get hurled.
Rocks.
You're pretty close.
That's what I thought. Like, that would be hilarious.
You got the first letter right on that one. What we're looking for is pellets. These little micro pellets are going to be accelerated by some really powerful lasers, and apparently, to the speeds that these things are going to get accelerated, they can actually move a 1-ton spacecraft up to about 350,000 miles per hour. And to put that in perspective, it means like getting out to the edge of the magnetic boundary of the solar system in like a few years, as opposed to like the 40 or 50 years that it took the Voyager spacecraft to get out there. So we're talking like way faster than anything that we have right now or have ever designed before. I don't know whether those things actually ever going to get built or not.
What are the pellets
there's
made
an
of?
asterisk that it'll get going that fast, assuming it survives being hit by these high velocity pellets.
How does it ensure that it's like evenly distributed across the surface to not generate a rotational effect?
Great questions. Those were not covered in the article that I read on Universe Today. But apparently this is like a legitimate proposal that is actually getting research dollars.
Can you make it stop? Right, presumably you'd want to go that fast. You can stop where you're getting, right? Or you just like fly right by real fast.
Fly right by.
Yeah.
Unless you have designed like the most amazing braking system in the history of the universe. As far as I know, we don't have that.
Yeah. So.
Somebody else's problem. I like that on the engineering. Like somebody will figure that out on the other end.
Go fast. You didn't tell me it had to stop.
I'm glad you brought that up, Lauren. That's actually something that doesn't get talked about enough when we talk about all these really fantastic ways of creating super fast spacecraft. It's like great if you can get something up to like 0.1% the speed of light. How do you slow it back down? Because you have to use just as much propulsion to do that in order for it to like be good for anything. So yeah, it's a huge problem in terms of the rocket equation. Rocket equation is, for those of you who don't know, it's how you calculate how much fuel you have to carry or some kind of propulsion system to speed you up and slow you down. That's the other side of it. And it turns out that part is pretty tricky. Well, I think Nick won, although I don't know how many points he has. So unless there's any contention, Nick, you are our champion for this evening. Nicely done, nicely done. And that was a lively round of the Astronomy News Quiz. So thank you all, and Madeline set the tone for that one on that first question. So Madeline, nice job with that. All right, that brings us along to what's up, Dr. Sam. And we already talked about the sunspot. We talked about the comet that's going to be visible in the next few days. If it's clear at night, and that's going to be around Polaris, by the way, over the next few days, the comet, you can see it. But there's also another really cool thing happening. The moon is going to occult Mars again. If you missed it last month, I think it was December 7th or 8th, the moon passed in front of Mars, and you could actually see Mars kind of pop out the other side of the moon a couple hours later. That's going to happen again in just a couple days, and you can see it not from everywhere in the United States, but in the southern portion of the United States. So basically, from Las Vegas south, from anywhere in Mexico, and from the northwestern corner of South America, you should be able to see the lunar occultation, and that's going to be on January 30th, so just under a week away. And if you're in Mountain Time, which is kind of like the middle portion of where it's going to be best visible, that's going to be from 7:30 p.m. to 11:30 p.m. Mountain Time. But you can do the calculations for whatever time zone you find yourself in. But it should be pretty cool. The moon will be almost full, I think about 3/4 of the way full, but Mars is bright enough, so you should still be able to see it naked eye, pass behind the moon, and then reemerge. And you can see it naked eye, but having a pair of binoculars or even a telescope will be even cooler. Mars is big enough in the sky so that with an 8-inch telescope, you can actually see some detail on the Martian surface. So that should be a good show if you get clear weather on January 30th that evening. So yeah, enjoy the lunar occultation of Mars that evening. All right, folks. Well, that brings us to our guest spot. We want to welcome Madeline again to the show this evening. And Madeline, again, thanks for joining us, and we really appreciate you being here.
Yeah, thanks so much for having me. I'm excited.
Wonderful. We like to start the guest spot by asking the guest the same question that we ask everybody else, which is, what's the one question that you wish everybody would ask you, but nobody ever does?
All right, well, I have two answers to this because I wasn't quite sure what the tone of the question was. So we'll start with the more casual, kind of out of left field question, which is, what's your favorite movie? And I feel like once you stop being a kid, people don't ask you that as much. But I'm a very passionate fan of the Jack Black movie School of Rock. I think that's the best movie ever made. It's a cinematic masterpiece. There's not a single flaw. It's perfect. But for a question that's slightly more oriented towards this, something that I feel like I don't get asked is, when did you first see the Milky Way? And where were you? And for always loving space and astronomy, I didn't see the Milky Way until I was almost 19 years old.
Wow.
I saw it at Green Bank in West Virginia because that was about the darkest skies I'd been to at that point. And it cleared up one magical night just enough. We weren't worried about the clouds for radio astronomy. Look at the Milky Way with your eyes. The clouds are a big problem. So.
Very cool. I'm trying to remember the first time I saw the Milky Way, and I don't remember, but my guess is it was probably around the time I was 10. I grew up in the San Francisco Bay Area, so I certainly didn't see it there. But when I was 10, we moved to this little place in northern Nevada called Yarrington, tiny little town out in the northern Nevada desert, and I distinctly remember seeing the Milky Way there. That's actually where I fell in love with the night sky. And so it definitely had a profound effect on me. But yeah, it's such a great question. I'm curious about the co-stars. Do you remember when you first saw the Milky Way and where you were?
I grew up in the woods, so I assume I saw it pretty early on, but I don't have a distinct memory.
Fair enough.
We used to go out to the Colorado River in between Arizona and California. I hope I'm getting this right. Is the Colorado River? Yeah. It passes right by Parker, Arizona. And we used to go and spend like a week at a time. And it's in the middle of nowhere, and it gets very, very dark there. So I think I was a little kid when I probably saw it there for the first time. It's beautiful.
Yeah, I was like Madeline. I was much older. I think I was 20 the first time I saw the Milky Way because I grew up in Philadelphia. No, not that great of a night sky. But I was actually like doing an REU, so a research experience for undergrads out at UCLA, and they took us to Palomar, which we mentioned earlier. So I got to go up in Palomar, and we spent the night camping, and I saw the Milky Way for the first time. Like, oh, this is what the fuss is about. Like, I get it now.
Nice. Yeah, and Mal, I don't know if it was just a coincidence that you came up with that question with the stuff about light pollution that we talked about, but that's one of the things that most people alive today can't actually experience where they're living. It's something like 60% of people alive today where they're living, they actually can't see the Milky Way. So it really is a profound experience. And that's why some people come to Wyoming and to Jackson to experience really, really dark skies. So yes, thanks so much for bringing that up. I appreciate it. So tell us a little bit about how you got into astronomy, the path that led you there, and what you're up to these days.
Yeah, so I have always really liked astronomy. My grandfather is somewhat of a hobby astrophotographer. And so I remember being very, very small and going to visit my grandparents at their house. And he always had like framed pictures that he'd taken of astronomical objects. And the Horsehead Nebula one is the one that I distinctly recall seeing. I'm toddling around desk height, and it's propped up against the desk, leaning on the floor. But it's a picture he took of the Horsehead Nebula. And I think that just blew my mind that was something that was real and out there and looked like that. And so from a very early age, I was entranced by that. And then I spent a lot of time watching The Universe on the History Channel growing up. That was my favorite show for a very long time. And that kind of introduced me to more than just the pretty pictures, but some of the concepts and the bizarre things that happen out in space. And so that's always been something I really liked. I bounced around different career ideas, in middle and high school, as I think a lot of people do. And I distinctly remember having to do a project about, what kind of school does your future career require? And I wanted to be an astronomer at that point. And then I saw they had their calculus, and I was like, oh, never mind. I'll find a different job. And kind of bounced around in that sphere of thinking towards astronomy for a while. But I really ended up loving math. And so I did my undergrad at a small liberal arts school in South Carolina, Furman University, go Paladins. And I very quickly decided to be a physics major because they don't offer an astronomy program. I figured physics was the next closest thing. And then soon after that, decided to major in math. So calculus and I became good friends, which was good. I used a lot of calculus. And then one of the professors in the department, the physics department, is actually a radio astronomer. And so he approached me about doing some research this summer after my freshman year. And so I accepted that. And that's kind of where the real tangible love of doing astronomy research started. I was working with him over the summer, looking at supernova remnant candidates. So we were looking at them in the radio to complement some X-ray observations. To determine properties about them that would tell us perhaps what these strange regions were. And that was really fun. I had a lot of fun messing with the data and visualizing these objects and kind of, the question and answer problems of, well, is it this? No, I don't think so. Well, what could it be? So that was really fun. But what really got me into the deep heart of radio astronomy is, so he had worked with a professor at UNC Chapel Hill, Dan Reichart, who organizes a program that they run once a week every summer at the Green Bank Observatory called ORIRA, which stands for Educational Research in Radio Astronomy. And the professor I was working with at the time, David Moffett, is one of the co-instructors of this program and suggested I apply for it. And I got in. That was very exciting. And so August after my freshman year, so August 2019, I spent a week living in a bunker at the Green Bank Observatory and hardly slept. I had like a very aggressive crash course in radio astronomy. And that was, to date, I think the coolest thing I've ever done. It's my favorite experience of my entire life so far. Nothing I've done since has topped it. It's really fantastic. And I think that's what really cemented the idea that I was quite happy doing astronomy research and that I quite liked the radio wavelengths.
That's awesome.
Yeah, like you mentioned, I'm definitely an early bird when it comes to observing. Late night observing runs are not my thing. And so radio astronomy is perfect for that because you don't care if the sun's up. So
Very cool. So what kind of research are you doing right now? Tell us about that.
yeah, so I'm working with Dr. Brad Johnson at the University of Virginia right now. And Nick, why are you laughing? We'll never.
Yes, I know, but I was wondering. You said CMB at UVA. And I was like, I wonder if she's working with Brad. Sure enough, yeah. No, we hang out on every week. Yeah, he's a great guy.
Yeah, so working with Brad, and I know Danny, you went to UVA for med school, so go Cavs. Danny, I think you're muted.
Danny.
Yeah, so I'm working with Brad Johnson. He primarily does cosmic microwave background instrumentation, but I'm kind of picking up more of the data reduction pipeline development side of that. But that's a later discussion. I'm a first year. But my current project is I'm actually looking at some spectral distortions, the cosmic microwave background spectrum. So the cosmic microwave background is all of this radiation left over from the very early universe that's kind of like a pervasive field of radiation. And it tells us a lot about these early parts of the universe that we can't necessarily look back at, in terms of optical observations or anything. It's too far away. But the spectrum of the CMB is pretty continuous. It follows it's called like a power law Planck spectrum. So it's a nice little rounded curve. But there's these spectral distortions that show up as tiny ripples in this otherwise very smooth spectrum. And the ripples I'm looking at in particular are from it's from the epoch of recombination. So when protons and electrons combined in this very chaotic sea of plasma to form neutral hydrogen, as well as helium, but mostly the hydrogen. And then those hydrogen atoms, when the protons and the electrons came together to form this hydrogen, it was not ground state hydrogen, it was some excited state hydrogen. And so as the hydrogen atom decayed back down to its ground state, that releases a photon. Those photons are the recombination lines, and those show up in the CMB spectra. So I'm working on, we've never actually done a ground-based detection of these lines. They should be there. And looking at that would tell us a lot about A, the epoch of recombination, and B, refine our understanding of recombination physics. So right now I'm working on simulating those signals and forecasting what you might need to actually have a significant detection from a ground-based instrument.
So why haven't those signals been detected from the ground? What's going on there?
Yeah, I think I think this is kind of a relatively new idea, looking at these recombination spectral distortions. And there are other types of CMB distortions. There's mu and Y-type distortions, which just emerge from largely Compton scattering. And those have been slightly more publicized. CMB instrumentation is not a very public world. But yeah, I just think it's a semi-new idea. And also they're incredibly weak signals compared to not just the CMB, but compared to literally everything else. They're incredibly weak. I mean, the CMB is not a particularly strong source either. So, a whopping 2.7 Kelvin. So that's already pretty faint. And then these ripples are super small on that. They're very faint. And when you're doing a ground-based observation, you have to look through not just all of space and the ISM and all of these much brighter signals, but you also have to look through the very bright signals of the atmosphere. So the proposed NASA satellite Pixie, which is another spectrometer, has been looked at as a potential space-based observation or detection of these distortions, because it has the added benefit of you don't have to look through the atmosphere. But the trade-off with a ground-based observation is, yes, you have to look through the atmosphere as well, but you can make a much larger dish.
Always the trade-off, right?
The trade-off. So I've been spending a lot of time looking at atmospheric molecules lately, and I'm not a chemist by trade, so lots to learn there.
Oh, that is so cool. So, all right, so let's say you get a detection of these very, very faint spectral distortions. What specifically are you hoping to learn from them?
Yeah, I think it's kind of a twofold desired outcome. One would be, hooray, we did it. That, sheds a lot of, important advice on what you might need to detect other types of spectral distortions in the CMB. And each of those tells you something different. So for instance, it can tell you more about Compton scattering during the early universe, or how recombination physics actually played out. And so being able to say, well, here's what we needed to detect the recombination distortions can also inform what you might need to detect, say, the mu and y type distortions of the CMB. So that would be, I have to say there's two. There's a yay, we did it. And then there's also a, how does this apply to other types of distortions, all of which can tell you really important things about kind of the physics that was happening in those otherwise very nebulous periods of time.
Very cool. Well, you have a timeline for when you think you're going to make that discovery?
Hopefully by the end of this semester. I'm trying to
All right.
have a paper published by the end of the summer.
There you go. That's good.
Yeah, we have a couple side projects too, which are maybe a little bit more exciting than very weak spectral signals. Largely right now, dark matter's a big thing. Everybody wants to know what dark matter is and what's going on there, because it's very yeah, right. I'd be like, all right, cool, yeah, sure, you can. And there's some complicated theoretical particle physics that I don't understand about these theorized particles called axions. And I don't really know a whole lot about the axion theory from the physics side, but the general idea is that in the presence of a very strong magnetic field, axions can convert into photons and vice versa. So in theory, if you observe these very strong magnetic fields, you might be able to detect the photon from when this axion-photon conversion happens. If you can connect that with any sort of dark matter through gravitational lensing or some other method, maybe that can facilitate a detection of axions, and what would be really nice would be some correlation between the two. So I'm actually working on that project also with Brad Johnson. So I'm observing, we've done some observations of the Andromeda galaxy just to get like a wide population of neutron stars. But I've also worked on some galactic center observations and isolated neutron star observations just to see if we can find anything, really. Axions would be great, dark matter would be even better, but anything would be good. So that's been really fun. But what works out nicely is it only happens in the presence of a strong magnetic field. So while people are like, oh, well, let's do like a lab-based experiment on Earth to see if axions are real, we can only make such a powerful magnet, but why not look to the most powerful magnets in the world, which would be neutron stars and very young pulsars. So that's a little more concretely exciting, perhaps, but also much more abstract and uncertain.
Yeah, pretty cool stuff, though.
Do the axion photons have enough of a unique signature? Like, is it enough to where if you saw it, you'd be like, haha, that's definitely what it is? Or
that's also a really good question, and that calls into question, how do we distinguish that from very small sources of RFI? Because those signals, again, are not particularly strong, these axion conversion photons. But the nice thing is the photons that are emitted in this conversion process will correspond to a distinct axion mass. And therefore, axions, I don't know what the mass is, but they have a different mass than other, say, baryonic particles. And so hopefully we could look at the photon and its energy, relate that back to an axion mass. That mass wouldn't match anything else. But definitely a tricky part of this is how do we distinguish it from anything else?
Yeah, there's some crowded places in space that you said you were looking at.
So. Oh, I know. These galactic center observations are horrible.
Yeah.
You can rule out every single strong signal.
Oh, that's super cool. Very cool.
Yeah.
So what? Where do you kind of see this research taking you? Do you think you're gonna stick with these two lines of research for a while, or you're gonna do something different for a PhD? What are you thinking?
Yeah, so a lot of it's still very up in the air. But
Always,
haha, there you go.
right?
But the general idea and structure that I have envisioned is I'll primarily stick with early universe cosmology and CMB observation work. The axions are more of a fun side project, and we'll see if that goes anywhere. But working with theorized particles is always tricky. But assuming I stick with this CMB line of work, I'm going to try to work with Simon's Observatory through the Simons Foundation to work on the data reduction pipeline. So the Simons Observatory scopes are supposed to go online within the next year, but that just means that thus begins the terrible process of how do we take the data and turn it into something even remotely usable. And that's kind of what I want to get into. So maybe you'll see me in Chile. I don't know.
Yeah, you might want to talk to Nick about that one. He had something to do with that project.
It's a few things, yeah.
Yeah.
Guess where I'll be from April through June or something like that.
I'm gonna guess Chile.
Oh, very cool. Well, that is super exciting stuff. We're just about out of time, but I'm just curious about like what your experience has been in the astronomical community, and what you want to leave us with in terms of like words of wisdom for for students who might be considering pursuing astronomy or as a career path or to study in college, and would you like to tell us about all that stuff?
Yeah, I would say I've had a really great time in astronomy so far. I've found that most people, if not all, are very excited to have you succeed because science is collaborative and working together gets you there faster, which has been really nice. I was a solar system ambassador for NASA for a few years in undergrad. Yay! That was really fun. That was a super rewarding activity, and I knew some people prior to this who had also been solar system ambassadors, and so they were always very willing to help. And that seems to be the general trend, is that usually if you have a question in astronomy, someone's willing to at least try to answer it, even if there isn't really an answer. And so I would say that my best piece of advice, and I think this applies for anyone, anywhere at any stage in their career, would just be to ask other people. You're not going to solve science alone. You're certainly not going to solve some of the universe's big questions alone. So just ask people, and you can get information, you can get opportunities. For instance, if my physics professor had not asked if I wanted to do research with him that summer, I would not have done that. Probably would not have gotten to Green Bank, and I don't know if I'd be where I am today. So I would just say, reach out, inquire about opportunities. If you know of an opportunity, let other people know that it's there. Because really just getting practice and being exposed to different things is how you find what you love.
Indeed, well said. Yeah, that is sage advice. Madeline, thank you so much for being with us tonight. It's been a pleasure. Our operations director, Maggie, who's behind the scenes this evening, has a thank you present for you, so she'll reach out and connect with you about that. So again, thanks so much for your time and sharing all your knowledge with us.
Yeah, thank you so much for having me. I had a really great time.
Yeah, likewise. And as always, thanks to the co-stars. We wouldn't have a show without you, so thank you so much for all of your time and expertise as well. And to all the other folks behind the scenes at Wyoming Stargazing, board of directors, all of our donors, and all of you watching at home. We're really psyched to have you with us. Thanks for a couple comments on the stream today. And we hope to see you next time in a couple weeks for the next Astro show. But until then, be well and don't forget to look up. We'll see you next time. Bye.